Okay, so in this lecture, we are going to discuss about the rock cycle. As we have already discussed about various types of rocks present in the earth crust. Okay, so let me remind you something about the types of rocks present. Okay, so as we know, in the earth we have three types of rocks present. One is igneous rock, the other is metamorphic rock, and finally sedimentary rock. Then, as we know, how igneous rocks are formed. So, igneous rocks are formed from the direct cooling of magma. These igneous rocks are formed. Then, when the temperature pressure condition of this igneous rocks changes, or when it undergoes weathering, whether it is physical weathering or chemical weathering or biological weathering, whatever it is, so all this transition may change this particular type of rock into either sedimentary rock or metamorphic rock. Okay, so this is the process that is happening. Simply, this process is known as a rock cycle. Okay, so simple by definition, we can say that from one rock to another rock, how it is changing, what all are the factors which are responsible for this transition from one rock to another. That is, we call it as the rock cycle. And why it is known as cycle, in the sense this process continuously going on from one to other, the other to next, then to magma. So this process is continuously moving on, hence it is known as rock cycle. Okay, so the rock cycle is a basic concept in geology that describes the transition through geologic time among the three main rock types. This is how we define the rock cycle in terms of geology. That is sedimentary, metamorphic and igneous. Okay. Then the rock cycle. Then we need to know what all are the processes, what all are the main processes that is happening in this rock cycle. What all are the main processes? Okay, so the processes include, first is the transition to igneous rock. As we know that the direct cooling of magma, that is the transition to igneous rock. Okay, that is, you say for example this will be the magma, and direct cooling or direct intrusion, this result in igneous rock. First process. Then secondary changes, this is the first process. Then second is the secondary changes. Secondary changes, as we know, what all are the secondary changes? Maybe pressure. Okay, pressure may change or temperature may change. Then weathering is also a part of that. So weathering. Okay, weathering. So this all are the secondary processes. So due to this secondary process, what will happen? This igneous rock, it will be changing to metamorphic rock or sedimentary rock. Okay, either it may change as sedimentary or it may change as metamorphic. In some cases, what will happen is that is when this igneous rock, when extreme temperature pressure condition persists, then it will again convert as magma, or it may convert as metamorphic rock, or it may convert as sedimentary rock. Okay, this entire process is what we call it as the rock cycle. So this is the process that is happening. First is transition to igneous rock. Second is the secondary changes. As we know, the secondary changes, you can add it, pressure change, temperature change, weather conditions, everything will comes under this secondary changes. Then transition to metamorphic rock, that is the another process. Then transition to sedimentary rock, which includes diagenesis process, everything. Okay, so this is what is known as the main process that occurs in rock cycle. Okay, then here it says about the various forces. As we know, this rock cycle, it is not a simple process. It is actually a very big process, but we can consolidate the process in simple words. That's it. So this rock cycle, it includes various forces. Due to various forces, various actions and various parameters, only this changes of rock from one form to another is happening. Okay, so now see you here, what are the forces that drives this rock cycle? This is very important. You should have to know what is main factor, what is the main factor that leads to this process. One is plate tectonics. As we know, plate tectonics, it is the movement of various plates. That is very important factor, that is plate tectonics. So plate tectonics, it is a very important factor. Okay, so plate tectonics, it is a very important factor. Then next is spreading ridges. Okay, plate tectonics is an important factor. Then next is spreading ridges. Then next is subduction zone. Okay, subduction zone. So the various forces during the subduction zones also this process may have changed or may change the trend of this rock cycle. Then next is continental collision. What is continental collision is also a part. Then accelerated erosion. Okay, in sometimes we may feel some accelerated erosion processes also happens. Then finally evolving process, that is when this action comes in existence, what will happen? A particular rock type may change to another, which may result to another rock type. So evolving process is also a very important process in rock cycle. Then next is the role of water. How water can change. How water can change the composition of various rocks to another, or how water can relocate. Relocate in the sense water can move. It can shift these materials to one place to another place. So that is also a force in this rock cycle. Okay. So once again, the forces that drives this rock cycle, it is very important to know all these things. One is plate tectonics, next is spreading ridges. Ridges is very important. Then next is subduction zone. So plate tectonics, ridges as we have discussed. Then subduction zone, subduction happens. So a subduction zones. Then continental collision. So collision of two continents also is a part. Then accelerated erosion, erosional activities of an area also. Here it indicates the movement of various debris. Then evolving process in the sense it will be either metamorphic rock, or it may be of either igneous rock, or it may be of either sedimentary rock, any of this that will comes under this evolving process. Then role of water, that is this flowing water can transfer or it can transmit the material from one place to another place. Okay, so these all are the forces. Yeah, so move on to the next slide. Yes, now the first topic, that is the transition to igneous rock. Okay, now we need to know about the transitions. Okay, first is the transition to igneous rock. How igneous rocks are formed. So when rocks are pushed deeper under the earth's surface, they may melt into magma. Yeah, when rocks are pushed deep under the earth's surface, as we know, when these rocks are in the earth's surface, they melt into magma as extreme temperature pressure condition exists. So this may melt as magma. Then if the conditions no longer exist for the magma to stay in its liquid state, it cools and solidifies into an igneous rock. Yeah, when this magma, now you think that when this magma comes out as lava, as we know, inside the earth crust, if it is the liquid state exists, it is known as magma, and if this magma comes out, it may call it as, or it may is called as lava. Okay, so mainly how this magma comes outside, it is because of this volcanic activity. So this due to this volcanic activity, okay, can imagine this is a volcanic area, this will be a volcanic cone, and through this the magma may upwell to the surface, and the upraised magma is known as lava. Okay, this is lava, and here it is known as magma. Okay, inside the crust it is known as magma, outside the crust it is known as lava. Okay, so this is the process happening in a volcanism. Okay, so volcanic activity is the main parameter how magma is spread over the surface. Okay. Then a rock that cools within the earth is called intrusive or plutonic rock. Yeah. And now these igneous rocks are also divided into two types, as we have already discussed about igneous rocks and types of igneous rock. So you may know about those things. Okay. Igneous rocks are of two types. One is intrusive igneous rock, or it may be known as plutonic igneous rock. Okay. Another is extrusive igneous rock, it may be called as a volcanic rock. So we can simply define this igneous rock as two types. One is intrusive or plutonic igneous rock, whereas the other is extrusive or volcanic rock. Okay, then what is intrusive rock? In some cases, the rock that cools within the earth, that is within the earth itself, if the rock is cooled, then it is known as intrusive. That means inside the earth itself, this rock gets cooled. That is known as intrusive igneous rocks. And this cools very slowly, producing a coarse-grained texture. So we have already discussed about the various igneous textures. What all are the igneous textures that we can observe in various kinds of igneous rock? So igneous rock, in the sense, this forms as intrusive igneous rock. This is also known as plutonic rock. Igneous intrusive rock means the rock which is cooled or which is consolidated within the earth. Within the earth, if the rock is formed, then it is known as intrusive igneous rock. Okay. Then next is, and what is the speciality of this intrusive rock? That is, it produces coarse-grained texture. That is, since it is developed or it is being consolidated inside the earth, it will be very big pieces. Okay, very big pieces. That is, it shows coarse-grained texture. So one example for this intrusive igneous rock, or in a sense plutonic rock, it is nothing but very simple example, granite. Okay, granite is an example of intrusive igneous rock. Okay, then next is extrusive igneous rock. As we have already said, the result of volcanic activity, that is the main reason why this magma comes out. Okay, when this magma comes out, as we already said, lava, it may be called as lava. So result of volcanic activity, magma, which is called lava, when it reaches the earth's surface, when lava is spread over the earth's surface, this may rapidly cool. Why? Because the temperature pressure condition inside the earth and outside the earth is different. Okay, inside the earth the temperature and pressure is very high, but outside the earth, that is the surface of the earth, the temperature and pressure is very low. Okay, that is the main reason for this rapid cooling. So this may very rapidly cool on the earth's surface, exposed to the atmosphere, and are called extrusive or volcanic rock. Okay, when these are surface exposed, when this lava is surfacely exposed, and when this temperature pressure condition changes, this will rapidly cool. This will rapidly cool, and what will happen? This forms as extrusive igneous rock. Then what all are the various types of extrusive, that is volcanic rocks? Okay, so when this magma cools on the surface, these are formed as volcanic rock. Then the basic classification is the same for plutonic rock. Okay, that is increasing the silica content. So classification of rocks is mainly done as the percentage of silica content. So we can give some example for this volcanic rock. It is basalt. Okay, so various example for this volcanic rock. One is basalt. Basalt is an example. Okay, basalt. Then you can go for dacite. Dacite is an example. Dacite is an example, and another example is pumice. It's very important that we all are using this rock, pumice. Okay, this all are the various types of volcanic rock. Okay, basalt, dacite, pumice. Okay, so we can move to the next one. Next process, that is the secondary changes. So now what all are the secondary process? That is, there are two processes. First is epigenetic change. First process that we came to know is epigenetic change. Epigenetic change is a secondary process that occurs at very low temperatures and low pressure. So what is the specialty of this epigenetic? Okay, epigenetic in the sense this process occurs only at low temperatures and low pressure. So in a low temperature, low pressure condition only this epigenetic change will happen. This is a secondary process. This may be arranged under a number of headings, each of which is typical of a group of rock or a rock forming minerals. So a particular rock forming minerals comes under this epigenetic change, usually more than one of these alterations in this progress in the same rock. Okay, so in same rock there may have various number of changes or number of changes will occur in a particular rock type. Now we need to know what all are the changes that happens to a particular rock which result in the formation of a group of rocks or various rock forming mineral. Okay, then first is silicification. Among that, first is silicification. Silicification, it is nothing but the replacement of the mineral by crystalline or cryptocrystalline silica is most common in felsic rocks such as rhyolite, but is also found in serpentine, etc. The first process is silicification. As the name indicates, when the soft material or easily leachable material from a rock is being removed, what will happen? That is, for a particular rock, there will have some minerals which can be replaced. That is, some minerals may be easily detached or easily leached from the particular rock. So these spaces should have to be filled with some kind of rock, as we have said as amygdaloids. Amygdaloid structure, vesicular structure. That is, when this vesicular structure is completely filled with some foreign material, it is known as amygdales, and hence the structure is known as amygdaloidal structure. The same thing, silicification, but here the thing is that in these spaces, what is being infilled? Here the replacement is done by the silica. Okay, silica is replaced. Mainly felsic rocks shows this kind of silicification process. Okay, an example is also given, rhyolite. Rhyolite is an example for a rock shows silicification. And also in serpentine also we will be able to find this thing. Okay, so the process is same, but thing is different. Materials are being filled in these pore spaces. Here silica is being infilled, so it is known as silicification. Okay. Yeah. Next is kyonization. So simply you can say that now here kaolin is being kaolin is being replaced for various other mineral. So kyonization is the decomposition of feldspar, which are the most common minerals in igneous rocks, into kaolin. Okay, various igneous rocks into kaolin, along with quartz and other clay minerals. There are various quartz minerals and also other minerals. It is best shown by granites and cyanides. Now this kyonization process generally seen in various granites and cyanide. Okay, so kyonization, it is nothing but the replacement of minerals as kaolin. Then it occurs along with quartz and other clay minerals. Then what are the examples showing this kyonization is granites and cyanide. Yes. The next process, it is nothing but serpentinization. Serpentinization is the process that is the alteration of olivine. Okay, most people may know about this thing. That is serpentinization. It is a very important process, that is the alteration of olivine to serpentine. Okay, for some exam also there will be some questions relating this various, that is which one is altered to which one and what the process is known as. So this should have to be kept in mind. Serpentinization is the alteration of olivine to serpentine. Yes, that is with the magnetite. Some amount of magnetite also will be there. Then it is a typical, that is it is typical of peridotites. Peridotites, as we know, it is olivine bearing. So it is typical of peridotites, but occurs in most of the mafic rock. Generally this serpentinization occurs in mafic rocks. Okay. Then next is urilization. Okay, urilization is a secondary hornblende replaces. Okay, hornblende replaces augite. Hornblende is replaced by augite, that is hornblende replaces augite process. It is a secondary process and is known as urilization. Okay. Next is chloritization. Chloritization, simply you can say that the chloride is being replaced. Okay. Replacement is chloride, that is the alteration of augite. Augite is changed to chloride. Augite in the sense biotite, either biotite or hornblende. It may be either biotite or hornblende. So this biotite or hornblende replaced to chloride and is seen in many diabases, diorites and greenstones. Okay, diabases, diorites and greenstones, we can observe this chloritization. Then next is epidotization. Okay, that is also a very simple process. Epidotization occurs also in rocks of this group and consists in the development of epidote from biotite, hornblende, augite or plagioclase feldspar. Okay, so epidotization occurs also in rocks of this group. So the same group of rocks also forms this epidotization, and here what happens is that it consists in the development of epidote from biotite, hornblende, augite or plagioclase feldspar. Any kind of these things will be replaced by epidote. Okay, so these are the various process. First one was silicification, replacement of silica. Then kyonization, replacement of kaolin. Third is serpentinization, that is the replacement of serpentine. Next is urilization, that is replacement of hornblende. Hornblende replaces this augite. Then chloritization, that is augite is replaced by chloride. Epidotization, that is epidote, the either biotite, hornblende, augite or something is being replaced as epidote. Okay, yes. Now the third process. First, transition of igneous rocks already over. Secondary changes, what all are the secondary changes is also over. The next is transition to metamorphic rock. Okay, transition to metamorphic rocks, that is rocks exposed to high temperature and pressure can be changed physically or chemically to form a different rock called metamorphic. Okay, as we have said that temperature pressure change is very predominant here, that is rocks exposed to high temperature and pressure. As we know, in the earth crust or in the earth crust, inside the earth crust, what is the temperature and pressure condition? Temperature pressure condition will be very high. Okay, so when this magma is being ejected, what will happen? This will crystallizes to form a particular kind of rock. When this temperature pressure condition of the rock is being again changed, what will happen? Obviously this will change to another type of rock. Then this metamorphic rocks is being formed. Then there are various types of metamorphism. Which depends upon the composition of the rock, then which area, whether it is orogenic belt or it is being any other fault zones or what kind of, whether it is chemically altered or whether it is physically altered. So based on all these things, there are various types of metamorphic process which result in the formation of this metamorphic rocks. Okay. The next is regional metamorphism, refers to the effect on large masses of a rock over a wide area. One such metamorphism is regional metamorphism. So regional metamorphism in the sense it covers a large area or a wide area is being covered. Regional metamorphism refers to the effect on large masses of rock. A very big large mass of rock is being affected and typically associated with mountain building even within orogenic belt. As we know, orogenesis is the process of mountain building. So this regional metamorphism process, this usually seen in the orogenic belt. Okay. Next is, these rocks commonly exhibit distinct bands of differing mineralogy, colors and foliation. Then every physical chemical characters of this metamorphic rock will be changed. Maybe initially it may be of igneous rock, but when it is being completely changed to a metamorphic rock, what will happen? The mineralogy will change, color will change, and the foliation, all this process may change. Then another main type of metamorphism. So that's all about renal metamorphism. Mainly orogenic belt, we can see this metamorphism. It includes a wide area. A large area will be metamorphosed. Okay. The next is another type of metamorphism, that is contact metamorphism. That is, metamorphism is caused when a body of rocks comes into contact. A particular body of rock comes into contact. This results in another kind of metamorphism known as contact metamorphism. Okay, when any kind of igneous intrusion comes under this contact, this helps heating up the surrounding country rock. So how this process, this contact metamorphism is done is that when any igneous intrusion is happening in nearby area, this will make heat in the premises, that is in the surrounding rock or the country rock. Okay, so what will happen? Obviously, when it is overheated, that rock also may melt. Then it will be mixed with the magma. And a new kind of rock will be formed in the particular area. This process is known as contact metamorphism. Okay, this contact metamorphism results in rock that is altered and recrystallized by the extreme heat of magma. Here you can see that the extreme heat of magma, or by addition of fluids. There are various hydro fluids, and the magma add chemicals to the surrounding rock. This process is known as metasomatism. So this process is also accounted here. That is metasomatism. That is addition of various chemicals to the surrounding rock. This process is known as metasomatism. Okay. Then next is, any pre-existing type of rock can be modified by the process of metamorphism. This you have to keep in mind. Any pre-modified process. It may be of either igneous rock or sedimentary rock. In case of metamorphic rocks also can be metamorphosed again. Okay, so any kind of rock can be metamorphosed again. Yes, so these are all the things regarding metamorphic rock. Now, finally the transition, that is transition to sedimentary rock. Okay, that is the transition to sedimentary rock. Here, the rocks are exposed to the atmosphere and variably unstable and subject to the process of weathering and erosion. As we have said, when this igneous rocks comes under atmospheric condition, what will happen? Obviously, continuous raining will be there, sunlight will be there, various glaciers will be there, snow effect will be there. So various parameters may affect this igneous rock. This result in what? Various weathering process. So weathering, it is of various types. It is of physical weathering, chemical weathering, or biological weathering. Then when these materials are weathered, what will happen? This may break into small pieces. This result in various erosional activities. Okay. Then weathering and erosion break the original rock down into smaller fragments and carry away dissolved materials. Then next process, what happens? Weathering and erosion break the original rock. So when a particular rock is being weathered, what will happen? It will break the original rock into smaller fragments and carry away dissolved materials. This will transport the material and it will be deposited some places. Okay. This fragmented material accumulates and is buried by additional material. What will happen? If a particular material is being break down and it is being transported to some other areas, this will be replaced by some other materials and this will continuously being for a particular area and it will be converting to another kind of rock. When an individual grain of sand is still a member of the class of the rock, it was formed from a rock made up of such grains fused together as sedimentary. What will happen? As we have said, here is an original rock was there. Then this rocks undergoes weathering, so there is breakage of these rocks. Again, due to this various material, here it is being again small pieces present here. Then these particular small pieces are again consolidated. This result in the formation of this sedimentary rock. Okay, that is the small grains are fused to form sedimentary rock. This is the transition to sedimentary rock. Okay, so these all are the various processes that is happening, that is transition of this various sedimentary rock, then transition of this metamorphic to sedimentary rock, and also various secondary changes, includes various replacements, etc. Okay, yes. Now, sedimentary rocks can be formed from the lithification of this buried smaller fragments. Now we know there are various smaller fragments, that is clastic sedimentary rocks, then accumulation and lithification of material generated by living organism, that is a weathering process. As we have said that the weathering are of three types. First is physical weathering. Physical weathering in the sense the physical features, that is mechanical breakdown of rocks only happening there, that is physical weathering. Second type of process is chemical weathering. Chemical weathering in the sense the chemical changes, maybe compositional changes or mineralogical changes is happening to the particular kind of rock, that is known as chemical weathering. Next is biogenic, that is sedimentary rocks, fossil or presence is happening there, that is. Then one more thing you have to keep in mind, that in sedimentary rocks only most of the fossils are present. Okay, most of the fossils are accounted in sedimentary rock, whereas some kind of fossils are also preserved in other kind of rock. But majority of the fossils are found only from sedimentary rock because it is very fine and is consolidated one. Okay. Lithification of chemically precipitated material from a mineral bearing solution due to evaporation precipitate sedimentary rock. Thus the precipitation process is happening and sedimentary rocks are formed. Okay. Clastic rocks can be formed from fragments broken apart from larger rocks of any type. So due to processes such as erosion or from organic material like plant remains. So that is the dead remains of plant fossil, that is flora and fauna. Then next is the biogenic and precipitate, that is the biogenic and precipitate rocks from the deposition of minerals from chemicals dissolved from all other rock types. So from all other various rock types also this biogenic process, that is of the plants and animals, these are also being dissolved in this rock. That is the main reason why almost all the fossil remnants is present in the sedimentary rock, and also various structures, that is these fossil structures are also very clearly imprinted, that is various imprints. Various imprints is also present in this sedimentary rock. Okay. Yes. So this is about the first thing, that is various transition changes to igneous rock, secondary changes, transition changes to metamorphic rock, and finally transition changes to sedimentary rock. Okay. Yes.